What's up, y'all? I can't begin to tell you how excited I am about this lesson I'm teaching today. It's a Pythagorean Theorem. It's one of my favorite lessons. Let me give you a back story about this since y'all can't fast forward me anyway. So the deal is, I did not know the math behind the Pythagorean Theorem. I could use it. But I didn't know the math behind it until I got to college. And one of my college professors by the name of Dr. Stiff, he asked us, why is a squared plus b squared equal to c squared? And none of us could answer the question. None of us. So I sat there in my feelings just like everybody else, and nobody knew. Because no teacher ever taught me why a squared plus b squared is equal to c squared. And so today I get to teach that lesson to you. I'm excited because you don't have to feel this small. You know, even a funnier story last year when we went to the Outer Banks, and we stopped at the School of Science and Math. Farrell, whatever his last name was. He he asked the girl that was giving us a tour, because you know the people in science and math are like the top people. He asked the girl, "Do you know why a squared plus b squared equals c squared?" That's the emoji that I should put up right then and there. And I was so embarrassed that he asked that, but then so proud at the same time. And she was like, no. And she was just like, I don't know why this boy's asking me this. He was like, because of what I'm about to show y'all today. So I'm excited about this lesson. And I'm happy that you will be able to know why, even though this is pretty simple, but it'll make sense. All right, let me stop talking and get to the lesson, because I'm already at a minute and a half. Y'all gonna be mad at me. All right, the Pythagorean theorem comes from the actual scholar Pythagoras. That's who it's named after. Where's my pen? All right, and so this theorem is something that he discovered, and this is what he discovered. This is what the Pythagorean theorem says. It says, for any right triangle, here we have a right triangle right here, for any right triangle, the sum of the squares of sides A and B add to give you the square of side C. Now, this does not make sense. Probably when you first hear me read it, it doesn't make a lot of sense, but I'm going to tell you what this means. So it says, for any right triangle, let me pick my pen tool. For any right triangle, the sum of squares of the sides A and B. So side A is, let me pick my highlighter. Side A is right here, right? This is side A. Ooh, that's too thick. But you gotta lose a little weight. Gotta lose a little weight. All right, this is side A. Woo, gosh, no. All right, I'm clicking on the other thing. It's not showing up. All right, this is side A, right? This is side A. That's fine. All right, and then we have side B, and then we have side C, which I'm trying to pick another color. All right, side C. So this is what this is saying. It's saying that the sum of the squares. So side A, which is this side right here, has this square. All right. And then if I make a square out of side A, right, this is what would be the square that it'll make. And then the sum of side A and the sum of the square of side B, if I made a square out of side B, this is what it'll look like, equals, or add to give you the square of C. All right, so this is the math behind this. Brace yourselves, people. This wonderfulness is about to happen. It's about to hit your life. So this is side A, right? Side A. A, if I were to make a square out of side A, which is right here, if I would make a square out of this, everybody, then it forms this 3 by 3 square. And the area of a square is the side squared. So A times A gives me A squared. Gotta make a big picture for y'all. A squared is a square. Okay, this side B right here, if I made B a square, then it will be this square by right here, which is a 4 by 4, which is B times B, which gives us B squared, right? Ooh, look at this magic. And then if I take the C, which is this side right here, if I turn that into a square, if I take the side C and make it into a square, it'll be C by C, which gives us C squared. Now watch Watch this magical thing that's about to take place. So we are saying that if you make a square out of side A, and that becomes A squared, and if you make a square out of side B, that becomes B squared, that those two squares will give you the square of side C, which is C squared. That's where the Pythagorean theorem comes from. It says that A squared plus B squared equals C squared. And now let's see this makes sense. So if this is a 3 by 3, then this square right here is 9. If this is a 4 by 4, then this square right here is 16. What is 9 plus 16? This is our 16. I want to do this as a highlighter. Come on, highlighter tool. Get your life together. You got to go skinny on us now. This is 16. It's not. What do they, people don't believe in skinny? Like, I don't understand. The highlighter does not believe in skinny, y'all. This is 16. And this is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We are saying that 16 plus 9 gives us what? 25. Because this is a 5 by 5 square. A squared plus B squared gives you C squared. If you make a square of these sides only in a right triangle, this only works in a right triangle. If you make a square out of each side, then we are saying that the square of side A plus the square of side B will give you the square of side C, Jesus. Hence our theorem, A squared plus B squared equals C squared. That is the math behind this. Now let's do some more math. Aren't y'all excited? Oh gosh, I just love this. It makes so much sense. It's visual. It makes sense. All right, let's learn about the actual sides. So we call this triangle, we said this is a right triangle. It only works for right triangles. These are the sides. A and B are called legs. The legs are the shorter sides of the right triangle, okay? They're the shorter sides, the sides that form the right angle. As you can see, A and B help to form this right angle. Ooh, that's ugly. This right angle here, okay? It does not matter which side is A and B. I just say that the vertical side is A and the horizontal side is B, but it doesn't matter because the legs are just the legs. What is differentiated is the hypotenuse. Hypotenuse. I can hear KT trying to say this word in class. Hypotenuse, okay? The hypotenuse is the diagonal line across from the right angle. We will never have to be confused about what the hypotenuse is or where it is. It's the diagonal line across from the right angle. That's the hypotenuse. It's always across from the right angle. Even if it doesn't look diagonal because this triangle, I shouldn't say diagonal. This is the side. Let me upgrade our language. It's the side, because it's not going to always be diagonal. And somebody's going to be like, you said it was supposed to be diagonal. And then I'm going to be like, you know, you're right. And sorry, it's not always diagonal. It is the side across from the right angle. And you'll never get confused with that. Okay, how does the Pythagorean theorem, how does this picture relate to the Pythagorean theorem? Oh, this is what I'm going to put in Ed Puzzle. And y'all going to have to answer that there. All right, so again, the legs are the sides that form the right angle. The hypotenuse is the side across from the right angle. It is the longest side of the right triangle. All right, I don't know how long this video has been so far, but let's move on. Today's lesson is not going to be a lot. So here we have 3 right triangles. How do I know there are 3 right triangles? Because of the right angle. How many degrees is in a right angle? 90 degrees, right? We know that 90 degrees are inside of a right triangle. So the Pythagorean theorem says that A squared plus B squared is equal to C squared, meaning that the square of side A, and A being squared, is A squared, and the square of side B, B is squared, is B squared. It makes A squared. And then the square of side C, C being squared makes a square, that if I add those two squares, they're going to equal up to the square of this side. Okay, so here, it's important to know A, B, and C. I told you that A for me is the vertical side, so I'll call this A. This is A, that's B, but C is the side across from the right angle, across from the right angle, across from the right angle. Let's go to those chunky highlighters again. All right, across from the right angle. All right, so A and B really doesn't matter, but I'll just say A is usually the vertical side. Don't get confused, okay? All right, so if I say, what's the equation for C squared? C squared is equal to A. Lord, I can't win for nothing today. C squared is equal to A squared plus B squared. I'm just switching the order, everybody. Just switching the order. Just switching the order. And that's the way I'm going to write it when we solve these problems, because I like reading equations from left to right. So here's the deal. This is all the math that I'm going to go through, because I've just blew your minds with the Pythagorean Theorem and explaining it, and some of y'all have to go back and rewind it and watch it again or whatever like that so you can get your answers right. Whatever you got to do what you got to do. But today we're going to use the Pythagorean Theorem to solve for the missing side C. All right, so it says, this is all out of whack. It says, write an equation. You should be right here. Move you. Write an equation to find the length of the missing side of the right triangle, then find the missing length, round to the nearest tenth if necessary. So here we have 7 and 10. Now we know that the missing side right here, I need a skinny highlighter alert. We know that this missing side is right here. This is the missing side. But what is this side? Well, this is the side across from the right angle. This side has to be C. So if we are missing C, then that means we have A and B. And I told y'all, it does not matter which one is A or B, but I try to visualize if I turn the triangle, this side would be A to me and this side would be B. So we are saying, this is what you're paying attention to me. You can write this down if you want to. You don't have to. But we are saying that C squared is equal to A squared plus B squared. They want us to find what C is. So this is what we have to do. We plug in everything that we know. We don't know what C is. So we have C squared is simply equal to A is 10 squared plus B is 7 squared. And this is what your notes and your problem in Fluke must do. You must write down everything I'm about to write down. If you skip anything, I'm not giving you credit, just letting you know. So now we have C squared is equal to 10 squared is 100 plus 7 squared is 49. All right, so C squared is equal to 149. But they want us to find C. Ooh, I'm so happy for Ed Puzzle, because now I'm about to ask you, how would I find C? How would I find C? Where's my calculator? I'm gonna have to pull up decimals. Okay, so I would find C by taking the square root, because we just want C. C is equal to the square root of 149, and that's not a perfect square. It tells us to round to the nearest tenth, so I need to go to Desmos. I'm sorry, y'all. I was going to pause the video and not do all of this because it's taking up time. But type in desmos.com. And all you need to use is the scientific calculator. You don't need the graphing calculator. Scientific right here, y'all. Scientific right there. Right there. And then it's the square root of 149. It said round to the nearest tenth. Everybody, the tenth is right there. I need the hundredths place, that 0 right here, to see if I'm going to round that up or stays the same. That 0 says stays the same. So this is C is approximately 12.2 units, because it didn't give us any units. That's how we find C. We do the same thing, y'all. We are missing this side here. This is the side we're missing. But what is that side? Well, that's the side across from the right angle. So this side has to be C. So the equation is C squared is equal to A squared plus B squared. All right, so C squared is equal to, I'm going to call this side A, I'm going to call that side B. So 6 squared plus 3 squared. We should probably start off with some numbers that actually, gave us perfect squared. All right, C squared is 36. And 9 squared, 3 squared is 9. So 36 plus 9 is 45. All right. And so now we need to do what? Take the square root. And when we take the square root of 45, that gives us 6.70, and we're rounding to the nearest tenth, so it's about 6.7. Now, usually you should do the squiggly because that's the approximate 6.7 units. Why are you beeping? Or whatever. What's this? All right, and the last one, y'all. 3 and 10. So the side that I'm missing is directly across from the right angle, so this has to be C. So therefore, C squared is what I'm looking for, is A squared plus B squared. So C squared is equal to, I'm writing fast because y'all are paying attention to me. I know y'all can follow this. 3 squared plus 10 squared. I'm saying this is A and that's B. 10 squared. So we get C squared is equal to 3 squared is 9 plus 100. 10 squared is 100. We get C squared is equal to 109. Take the square root, take the square root. C is approximately, come on now, 109. 10.4, that 4 right there says, hey, 4 stay the same. 10.4, 10.4 units. All right, so what have we just found? We just said that this is approximately 10.4. We just said that C right here is approximately 6.7. And we just said that C right here is approximately 12.2. Why is it important? Because C is the longest side. If you get a number that is smaller than A and B, you did something wrong. Oh, let me get in your face real quick. If you get a number that's smaller than A and B, you did something wrong. It's going to be a question. I'm not playing with y'all. All right, 3, 6, and 6.7 is longer. 10.4 is longer than 10. All right, so this is what you're doing in Floop. It's coming up real soon. I miss y'all. I really do. Appreciate y'all for doing your work. Appreciate you really much, really much. A whole lot, really much. I don't know what that is. All right, you're doing 1, 2, and 3. You do not have to draw the triangles. I was going to ask y'all to draw them, but you do not have to draw the triangles. And you're putting, this is number 1, this is number 2, and this is number 3 into, I think I'm making this Edpuzzle. Yeah, so you're answering them in Edpuzzle, and then you're uploading them into Floop. Or I might not do both. I don't know. It's how I feel when I get done making this video. All right, you must do all this work here. You see all this work? You see, it's coming up in a second. You see all this beautiful work? You see all that work? Yes, you must do all of that. So don't play me. You won't get no grade. I don't care. You won't get anything from me. All right, y'all. I appreciate you. I need a healthy, let me not say fat. I need a healthy. This has been a beast mode production. Appreciate y'all. Thank you for caring about your education. I'm out in a second. Once I click the out button. Once this is done. All right.